Hello engineers, this is Mr. Hernandez and I'm back with the second half of our Simple Machines lesson. So just like with the first set, if there's anything that's written in red, that's something that I think is important and you should write it down in a notebook. And for this assignment there will be another little quiz attached to it. That way you can check if you understand all of the simple machines. So make sure you have that notebook, make sure you take good notes, and get yourself ready for that quiz. Alright, let's go ahead and jump into it with a little recap. So this is just to cover what we went over last week. So we talked about machines, and machines are just tools that we can use to make our work easier. Remember, work here has a scientific definition. It's all about moving things. So if you push on something and you move it, you're doing work. Alright, so that's machines, and they can help us do work in two ways. So either they can increase the force and decrease the distance. In other words, they can make you stronger, but you're not going to be able to move things as far. Or they can do the opposite. They can decrease the amount of force that you're applying and increase the distance. So that's good if you're trying to move faster, but you don't need to be as strong. Alright, so that's machines in general, but our focus today is on simple machines. And simple machines is this set of 6 machines that people and engineers have been using for thousands and thousands of years. So these 6 simple machines consist of the lever, the wheel and axle, and the pulley, which we have all talked about before in our presentation last week. The new ones that we'll be covering today are the inclined plane, the wedge, and the screw. This is going to be the inclined plane. So the inclined plane is the absolute simplest of all the simple machines. It's so simple you might look at it and think that's not actually a machine, but when you look at how it works, you'll see it's doing the same kind of job as all the other ones. All it is a flat surface that connects a low spot to a high spot, also known as a ramp. This makes it easier to lift things up. So if let's say that we have this block here and we need to get something up to the top of it. Well, normally you'd have to just pick it up. You just have to apply force to it and pick it straight up until you get to the top. But with an inclined plane, instead of going straight up like this, we can go up this path. And that means that we're going to be pushing this way. And that means that we don't need to lift the entire weight of our object the entire time. Now it does mean that we have to move a lot farther to go all of this distance instead of just like this, but this makes it a lot easier to lift something up. Now there's a couple of ways that we can use this, but we're just going to summarize this because the inclined plane is so simple. So go ahead and pause if you need to write this down, and you can save off on drawing the diagram for the next page. So we're going to take a look at this once again. So with the inclined plane, the usefulness of it is just going to depend on how long the inclined plane is. If the ramp is longer, that means it's going to be easier to lift. But obviously you have to go a lot farther. Here we're going all of this distance with the long ramp, but with the short ramp it's just this distance. Now the shorter that ramp or inclined plane is, the harder it's going to be to lift an object up there. Think about going up a really steep hill and how tired you get, but you're going to do it in less distance. So that is the inclined plane. I would draw this diagram here, and you can even label them. This is the long ramp, this is the short ramp, although that should be pretty clear here too. And go ahead and pause if you need to finish writing and drawing all of this, and then we're going to go ahead and move on. So with the inclined plane, its variations are actually whole new machines. So this is the wedge, and a wedge is what you get when you take two inclined planes and you stick them together. So here's a diagram of a wedge. So you can imagine splitting it in half right here, and then we've got one inclined plane on the left and one inclined plane on the right. And what the wedge does is it splits, or it cuts things apart. You can see how it changes the direction of the force here. So you can press down on it and the wedge presses outwards. Now anything that does this job, anything that is splitting or cutting, is a form of a wedge. So if you can picture something like an axe that has a wedge shape on the front of it, but even things like scissors, that cutting edge on the scissors, those are wedges as well. So that's a good example of kind of a simple machine that's hidden in another machine. Now wedges act just like the inclined plane. If the wedge is longer, that's going to make it easier to split or to cut these apart. But you have to move much, much farther to split them just as much. If it's shorter, you're going to have to increase your input force. You're going to have to hit it harder to do the same amount, but you're not going to need as much distance. All right, now let's go ahead and take a look at our last simple machine of the day. That's going to be the screw. And the screw is another type of inclined plane. It's a little bit hard to see here because we're used to seeing screws as one whole thing, but the screw is actually an inclined plane that's wrapped around a cylinder. So here's the cylinder, it's the center here, and the inclined plane is going around and around and around all the way up. That's the thread that you see on the side of a screw. And what the screw does is it turns your twisting force up here into a much larger up and down force. And that makes them really useful to either lift things. We actually use quite a lot of these on our 3D printers to lift the different parts of it up and down. But you're probably more used to seeing screws used to hold things together, where people might drill two things together with a screw. Now go ahead and pause so you can write this down, and then we'll take a look at how a screw works. So this animation shows how that inclined plane gets wrapped around the cylinder. So you can see that top edge on it becomes all of the teeth on it. I'll let this play a couple more times since it goes by so fast. Alright, now let's go ahead and move on. So just like with the ramp or the inclined plane and the wedge, if that inclined plane goes over a longer distance, that's going to increase your force. Now, what's a little bit tricky with the screw though, is that it can be hard to tell if you're covering a longer distance. For example, between these two here, I want you guys to go ahead and guess which one of them is increasing the forces more. Now, because the inclined plane is wrapped around the cylinder, the longer distance actually shows itself with tighter threads. So if you see that the threads are closer together, and you can see the spacing here, if you can see that the threads are closer together, that's a longer distance. That is giving you more force. So between these two types of bolts here, or screws, this one has a much wider gap than this one. So the top screw is the one that is going to increase the force more. And that is our last simple machine. So make sure that you guys took good notes, and right after this video you can go ahead and take the quiz that's down below. Good luck. Let me know, or let your teacher know when you've taken it, that way you can get your score back. So next week we're going to be finishing up our talk on simple machines, so just keep an eye out for that new lesson, and have a good day.